Question 8, part A. On the grid, draw the graph of y equals minus 2x plus 4 for the x values going from minus 1 to minus 5. So that means in terms of our x values on our graph, we need to make sure that our straight line basically goes up to that left-hand side and right-hand side. So if I drew this as a line, that's not acceptable because there's going to be a missing bit here and a missing bit there. As far as being able to draw our straight line, there's two ways you can do this. One of the ways involves a table of values where we substitute in x values. Makes sense to pick minus 1 and 5 as two of the values. How many values you put in between is entirely up to yourself. Technically, by subbing in minus 1 and 5, that's all that you actually need, because once you have 2 points on a straight line, you can just join the dots. But you could also find 0, 1, 2, 3, 4, or even some of those if you so wish. If you find, or if you substitute minus 1 and 5 in, what you will get is your y values is you will get 6, and you will get minus 6. Now, plotting these points, we are going to end up with this here, and 5 minus 6 is going to give us that there. And if you join these lines up, what you're going to end up with is the following. You'll end up with all these points here. Of course, if you did any more of the table of values here, you would confirm these points. And our straight line, which of course would be with a ruler, we join like so. Anything extra that you draw here, or anything extra that you draw there, it doesn't matter whether or not you have it or not. As long as you have the line between the x values of minus 1 and 5, then we are good to go. That is that straight line drawn. Now, the quicker way of doing this, given our formula, if you think about the fact that it is y equals mx plus c, c is the y-intercept, which tells us that 0, 4 is a point on our line, and our gradient is minus 2, which means that our rise over run is minus 2. And minus 2 is the same as minus 2 divided by 1. So if you have a gradient that's not a fraction, you can always turn it into a fraction by writing it over 1. So what that means is, starting from our point up where we cross the x-axis, this minus 2, 1 means that we go down 2 for every 1 that we go along. So we go along 1, down 2, along 1, down 2, which I'm just going to show here using these red arrows. Along 1, down 2, plot another point. Along 1, down 2, plot another point. That is a quicker way, technically, of being able to get a few points. Keep following the pattern all the way down to the end. And of course, for going back the way, we're simply going to do the opposite. But given that you'll have all these points lined up there, you'll know straight away where this point's going to go there. That's a quicker way of being able to draw a straight line without a table of values. Either way, we have our line. Let me just make this a little cleaner for the next part. Okay. B. Show by shading on the grid the region defined by all three of these inequalities. So we have three inequalities that have been given that I'm going to color code here. So in terms of shading inequalities, what you technically do first is you sketch the graph of the equations. Now, it just so happens that this orange line, actually I should really color code that differently. This navy line is the one that we just drew in this previous question. So that line there we already have drawn. If we sketch the other two, if we sketch y equals minus 4, and we sketch x equals 1, we're going to get the following lines. First of all, the blue one represents the equals, y equals minus 4, and the brown one is going to represent x equals 1, which, excuse the fact that this is not perfectly straight, that there. Okay, so that's us sketched this, that is us having sketched that, and we already had our first graph. Now, in terms of interpreting the inequalities, basically, if you have an x less than something, then that means you're going to be left of it. If you have an x bigger or equal to, it doesn't matter if there's a line underneath it, you're going to be to the right of the graph. So, given this one here, we're basically going to be to the right of the brown line. So I can represent this by just drawing a couple of arrows. The area that we're interested in is going to be the right of that brown line. Anytime you have y's, irrespective of what else you have, if you just have y's full stop, if it's y less than, you're going to be below that graph. And if it's y bigger or equal to, again, you're going to be above. So based on the blue line here, we are going to be above that line, which means I can use little arrows here to show that we're going to be above the blue line. And lastly, the navy one here is a less than or equal to, which means we're going to be below that line. So I can draw that by doing little arrows pointing below the navy line. Now, in terms of our final answer, which involves shading on the grid, you're basically looking to shade the region that all of the arrows point into. So you've got to be above the blue line, you've got to be right of the brown line, and you've got to be below the navy line, which basically gives us this. It doesn't tell us to, oh no, it does, it tells us to label our region R, so I put R in there, and that's us done.